We need to show that a squared, b squared, and c squared are in arithmetic progression whenever cotangent of a, cotangent of b, and cotangent of c are in arithmetic progression. So let us begin. So we'll start with a given condition. So we're given here that cotangent of a followed by cotangent of b and cotangent of 3. So these three numbers are in arithmetic progression. Now since they are in arithmetic progression, it's clear that 2 times the middle term, which is cotangent of b, that must be equals to the sum of the first term and the third term. Now we will convert cotangent to it's the ratio of cosine and sine. So we have 2 times cosine of b over sine of b. So this will be equals to cotangent of a, which is the ratio of cosine of a to that of sine of a, plus cotangent of c. So that is cosine of c to that of sine of c. Now what we can do here, we can use the law of cosines to rewrite the cosine a, cosine b, and cosine c in terms of its sides, a, b, and c, and lowercase. Similarly, we can use the law of sines to convert sine a, sine b, sine c to its respective sides. So let's specify the law of sines and the law of cosines. Now we have a triangle ABC, that the sides opposite angle A, angle B, and angle C will be represented by the letter A, B, and C in lowercase. Then we can define cosine of angle A in terms of its sides as b squared plus c squared minus a squared over 2bc. Similarly, we can define cosine of angle B and cosine of angle C in terms of its respective sides. And the law of sine states that the ratio of side A to that of sine of the angle opposite to it equals the ratio of side B to that of sine of the angle opposite to it, and this is also equals to the ratio of the third side to that of sine of the angle opposite to side C. Now what we'll do, we will use the value of cosine A, cosine B, and cosine C. Now we also need to find out the value of sine A, sine B, and sine C. For this, we're going to consider the law of sines and consider that these three ratios be equal to a constant, and let's call it 1 over lambda. That means we can represent sine of A as A multiplied to lambda. Then sine of b will be equals to b times lambda, and sine of c will be equals to c times lambda. So we'll use this value. That means we now have to multiply to cosine of b. So cosine of b will be c squared plus a squared minus b squared whole divided by 2ca. And since we have sine b, so sine b will be simply lambda multiplied to b. So this will be equals to cosine of a. So cosine of a is b squared plus c squared minus a squared divided by 2bc. And from sine a, we're going to get lambda multiplied to a in the denominator. And for the second term, we have a squared plus b squared minus c squared whole divided by 2 times ab. And for sine c, we have lambda multiplied to c. Now clearly we see that we have lambda times 2abc as the common denominator on both sides. We can factor that out, and we are now left with 2 multiplied to c squared plus a squared minus b squared. This will be equals to b squared plus c squared minus a squared plus a squared plus b squared minus c squared. When we solve this, we are going to get that a squared plus c squared, that will be equals to 2 times b squared. And whenever this particular criterion is met, then we can say that a squared, b squared, and c squared, these three terms are in arithmetic progression. Hence proved.